Today we are going to discuss about a very interesting model. The goal of this model is to see if mobile pastoralists can spread out ideally when they have freedom to move and access to shared resources. The model tests three movement rules to see which one helps which one helps the pastoralist to spread out most effectively. So, to start, could you please introduce yourself before our chat?
Yeah, I'm Mark Moritz. I am a professor in anthropology at The Ohio State University, and I've worked with pastoralists in Cameroon and now also in Oman.
To begin, could you please explain the primary purpose of the model and what inspired you to create it?
Okay. So the main purpose of the model is to examine whether pastoralist individual movement decisions by pastoralists result in an ideal free distribution, i.e. a distribution where the distribution of resources matches or where the distribution of pastoralists matches the distribution of resources. Or in terms of complexity science, whether the governance of resource systems, or in this case, common pool resources, works as a self-organizing system. And this model was part of a larger research project that examined how mobile pastoralists in the far north of Cameroon manage common pool grazing resources. In the situation of open access, and the conventional explanation and prediction is that in situation of open access, there will be a tragedy of the commons. But that was not the case in Cameroon, where I conducted my research. There, I worked with mobile pastoralists that had open access to common pool resources, but there was no evidence of overgrazing. So I hypothesized that this system worked as a complex adaptive system or a self-organizing system. And we conducted both spatial analysis as well as ethnographic studies in which we studied the movement decisions that individual pastoralists make, and we studied the outcomes at the population level or the landscape level. But we could not empirically study how these individual movement decisions and of all these hundreds of pastoralists resulted in an ideal free distribution. So agent-based modeling was the perfect tool to examine these dynamics of this complex adaptive system.
Now let's talk about the development process. What were some of the major challenges you encountered while developing this model, and how did you tackle them in the process of development?
One of the challenges was that I didn't know how to model, so I had to learn from scratch. Fortunately, we used NetLogo, which is relatively easy to learn. There's lots of examples and models and tutorials. I also worked with a team of both a colleague here at Ohio State and students, and so I could ask my collaborators for help. The main challenge that we encountered was that our model is relatively complex. And for the longest time, it did not work, and we could not figure out why it did not work as we expected to do. Turned out later that we had one too many parentheses in our model, and when we found that bug, then everything worked as predicted. But it took us a while to figure out where the error was. And so the complexer the model, the more challenging it is to get the model right.
Exactly. So, regarding the results, what are the main insights derived from the model analysis, and how can these improve our understanding of this important issue?
The main insight is that this particular pastoral system in the far north region of Cameroon works as a self-organizing system, and that the system is sustainable and efficient. And in later studies, we've also argued that this is not just true for pastoralists in the far north of Cameroon, but that many pastoral systems work as complex adaptive systems. The other insight is that simple rational actor models in which actors or agents maximize short-term profit or short-term gains are not efficient and not sustainable. In our case, when we gave our agent rules where they maximized intake and where they maximized their gains, those simulations, the system crashed. One of the things we did is we found in our ethnographic studies that pastoralists generally return to the places that they have been before, because their cattle know these places, they know the pastures, they thrive in these pastures. And we described this as, they described it as habitude. So the animals are habituated to these pastures. And when we included that information in our model and in the rules that agents follow when they make decisions about where to move, it leads to more sustainable and more productive outcomes. In other words, the culture matters, and in this case, it leads to better outcomes.
So you have made your model available using ComSys.NET platform. What kind of challenges and obstacles you faced in making this model available and accessible on this platform, and what steps did you take to resolve these challenges?
So I was aware of the ComSys and the model repository as I started doing the study and building the model. I think then it was called OpenABN, and now it's called the Computational Library. And so I always plan to publish the model in the repository, as well as ask for peer review of the model. Uploading and publishing the model in the repository was straightforward and simple. And the main reason was that we used the overview, design, and details protocol from Volker Grimm and colleagues to describe our model. And so when we uploaded the model and submitted it for peer review, most of the work had already been done. The advantage of uploading the model first and make it available privately and then later publicly was that we could share the model with the reviewers of our paper. So the reviewers of our paper could download the model and replicate our studies. And then later, when our paper was accepted for publication, we made the model public in the repository, and it came out the same time as the paper came out.
Finally, looking forward, what are the next steps for this research and model and work? And are there any follow-up studies planned to expand on this model and work?
So the study out of which this model column has ended, so the funding has ended, and we did all the things we want to do. I'm currently working on a book manuscript about this project, including, which also has a chapter on agent-based modeling, and how we built the model to evaluate our hypotheses. As I'm writing that chapter, I also realized that there's many questions and parts of the model that we have not yet explored. One of the reasons for publishing the model in the repository is that other researchers who download the model, expand on it, use it to explore some of the dynamics. So there's still many questions that remain unanswered. The other thing I've been doing is I've been collaborating with colleagues here at Ohio State, and we're modeling a prehistoric pastoral system in Dhofar, Oman, in the Southern Arabian Peninsula. There we conceptualized the pastoral system as a coupled human and natural system that cycled between periods of territoriality, in which pastoralists defend common pool resources, and periods of open access to common pool resources. And again, these social and ecological dynamics happen at time scales of decades, hundreds and thousands of years that are very difficult to study empirically. And again, agent-based modeling is perfect for that. However, this model is even more complex than our Cameroonian model, so we're still working through some of the bugs of that model.
Thank you very much for sharing your insights on this valuable model.
Yeah, I hope it's useful and I hope it's clear.